Welcome, my name is Okubo Benebo. The subsistence farm, evolving into a state of apparent steady operations at the conclusion of planting of the target crops, does not necessarily conclude the build-up of the farm. Rather, the interlude between the end of planting and start of harvesting is, in fact, a grace period to mentally reflect on the post-harvest context and the advantages and hardships that might arise from the context. After all, the use of the farm is not expected to be a one-off operation, but rather an ongoing operation, and hence requires continuous improvement. And the looming post-harvest context is the sort of rinse-repeat circumstance that needs to be fully embraced, and the manner of resolution developed into a routine. An obvious situation that would certainly arise of the post-harvest context is the farm plant's waste collective of stems, husks, vines, and what have you, and the mechanism for disposing of them, which would be either by utilization for power generation or as biofertilizers, and the impact of these needs on the function tasks that are being performed, and that brought the farm into the prevailing operating state. And then identify those operations of the key functions that require improvement, either in farming process improvement design or underlying technology improvement retrofit designs. Particularly worthy to reflect on are the deficiencies that have obtained in course of bringing the subsistence farming into the state of prevailing operations, and the manner in which the deficiencies tie in with the disposal plans of the farm waste. The portion of the farm collective waste for processing into power generation ties in directly with the possible circumstance of the potential shortfall of the power available to operate the farm, considering that the scoping of the essential crops forced an enlargement of operations not initially planned for as intrinsic to the farming. The currently in use initial design was improvised to get started, but now a more reasoned design is needed. As currently in use, the burner only burns gas because the methanol fuel produced is fed to the burner as gas, having been heated with ambient heat to cause continuous evaporation. There is therefore no means to adjust the methanol loading to increase the thermal load output. Consequently, one such underlying driving technology among others that needs improvement design is the biofuels-burner of the electric power generator. Understandably, the use of integrated technologies with the controlled microorganisms' metabolic utilization of the post-harvest farm biotic waste is anticipated to provide biogas and alcohol, respectively. The evolving circumstances then is that either these would be used to replace the methanol entirely or be used to supplement that output of the methanol, depending on the stability that has obtained with respect to the methanol feed raw materials supplies from the supply chain. However, preferring to be contented with raw materials, the farm waste, being produced locally over raw materials that are supplied externally, and hence opting for replacement of the power generation, then an immediate specification could be that the upgrade improvement have the burner utilize the composite of the two states of matter of the biofuels available for burning. Yet, support of sustained use in operations imposes additional specifications, though this time around these are not of design but safety requirements. First, to the extent possible, the fuel burner exhaust pipe should be high enough that the exhaust opening is about 10 feet from the ground. Second, the device must be encased in a larger space or cylindrical pipe to protect the farmer's collective from being singed by the hot gas pipes. However, the encasement cylinder need not be of same height as the exhaust. Of course, this brings the matter of energy extraction to a successful conclusion. In synopsis then, this episode entitled Subsistence Farms Power Generation Biofuel Burner Upgrade provides a design for deployment in subsistence farms for electric power generation based on burning biofuels produced on site, whether or not in the matter state of liquid, gas, or of both states. The driver rationale guiding the upgrade design of the power generation biofuel burner is the fundamental mindset that improvement subsumes building on existing resources, thereby requiring preserving the fuel gas burning state of the current burner. In principle, the fuels avail the farm with chemical energy resources from which the chemical energy is extracted. The functionality of the current burner is the extraction of the chemical energy by combustion, otherwise thermal decomposition by controlled burning, and then the capture of the thermal energy for producing electricity, which obviously can be applied to do work. Improving on this while still using thermal decomposition by burning, the two states of matter of the fuel being gas as is the biogas and liquid as is the bioalcohol, the task of composite burning would then require the alcohol be brought into the same state of matter, preferably the matter state of biogas or gas. Of course, the phase conversion design is specific to each designer, and so better to elicit a set of design specifications that should guide the rationale of design. Based on this requirement of preserving existing performing state, it is fairly straightforward then to perform and evolve a set of design specifications for guiding the design of the device. Admittedly, the burning of the biogas raises some issues of risk, the source of which is the presence of hydrogen in biogas. After all, biogas fuel is a mix of methane, carbon monoxide, and traces of carbon dioxide and hydrogen. The hydrogen in the mix is well known as highly explosive because of its low flammability conditions. The design, therefore, must prevent, in fact, suppress the explosive conditions for hydrogen, and if necessary, actually leverage the presence of the hydrogen to improve on the flammability conditions of the overall biofuel. Further, significantly, there must be complete combustion of the biofuel gas mixed with the air. There can be no soot, as the cleaning of the inner walls of the burner would not be possible during the time spans of operations of power generation, which are expected to be spanning the spread of 11 months and 12 months. Yet, of utmost importance in designing for rapid mixing is that while attainment of flammability conditions within a short flow length is desirable, the ignition effect must also not result in any form of flame propagation. The design must explicitly suppress the potential for the occurrence of flame propagation. The design task then is the design of the mechanism for effecting the controlled burning. The upgrade design of the current electric power generator can be implemented with three retrofit devices: thermoelectric transducer, improved biofuel burner, and biofuels distributor, with the fuels being gas and alcohol as liquid. The improved biofuel burner, which performs the controlled burning, is actually two different burner sub-devices fused into an integrated device. Geometrically, it has a shape somewhat like a bottle, but with fatter neck section. The neck remains of size that continues to be sleeved by the existing thermoelectric transducer. Somewhere about the base of the neck is placed a pot for flame ignition. The exact design of the flame igniter is at the discretion of the designer, but definitely with the requirement that a blowback of flames in any form does not occur. Both the gas and the liquid biofuels flow into the burner through the base. The base section of the liquid channel is of dimension enough to sleeve the body of the existing burner. With the bioalcohol converted from the liquid state to gaseous state, both fuels attain the same state, and then going forward therefrom and until the burning actually occurs, the design of the device can be considered from a unified perspective. In development of the design specifications of the burning of just gaseous biofuels. In the gas burner subdevice, the air and the biogas enter the burner section in concurrent flow, of which the biofuel gas flows in a tube jacketed with another small pipe, in the annulus region of which flows air. There is affixed a mechanism at about the outlet of the concentric flow pipes, a means of inducing very rapid mixing to bringing about virtual homogeneous state of mixedness within a very short distance, downstream from the reference point of injection of gas into the air, or the mixing of the gas and the biogas. The biogas fuel simply is mixed with air without the need for prior change of its state of manner. However, in the liquid burner subdevice, effecting the change of state of matter of the bioalcohol, the liquid, while also flowing in a tube jacketed with a pipe as with the biofuel gas, but not air flows within the pipe in this jacket. Rather, some of the post-combustion gas which is pumped into the annulus to prevent the alcohol, to preheat the alcohol to vaporization and then to ignition. The alcohol, being liquid, turns into a gas and further advances the chemical energetic state of the gaseous mixture of air and the alcohol to the flammability state. The behavior is design implemented by two means: aspiration followed by heating of the droplets dense gas fumes into superheated vapor, and simple boiling to vaporization and then additional heating of the vapor into superheated state. The latter vaporization scheme is used as start, and then after ignition and burning of the biofuels, the quantity of liquid vaporization is increased by switching to the former upon the recycling of the hot gas on the liquid. The recycle stream design is a bunch of tubes with flared end opening set at somewhat above the fuel's burning region, so that upon the effective combustion of the biofuel accompanied with the production of hot effluent gases, some of the hot effluent gases flow into the recycled tubes, get extracted as per designer, and flows back now to the base, and there flows into the annulus sleeving of the liquid biofuel feed tube. The hot gas is effectively recycled back to the subdevice as per design prior, as required heat source for the thermal generation of the vapor of the alcohol that subsequently gets heated to superheated state. The fuel distributor performs sort of load balancing while supplying the fuels to the burner, and is designed to embody the current burner trunk where the gases mix prior to flowing to the flame region. The new use of the body of the existing burner is to deliver liquid fuel to the burner device. This unit slides down the center of a series of tube-in-tube connected to a gas distributor at the base. The outer cylinder annulus carries air, and the inner tube, the hot effluent gas, recycled. Of course, this will be easy to achieve by pumping the hot air in an outer annulus jacket concurrent to the gas fuel flow, However, given the need to rapidly reach flammability conditions, the air supply stream's flow rates will need to be controllable, preferably with a valve of some sort. The recycled hot gas stream may be used to also preheat the air for maximum assurance of achieving flammability at the gas homogenization region. The conclusion that could be drawn at this time is that with careful consideration, a gas cum liquid fuel burner has been developed and is an improvement on the existing burner and readily can be adopted in every subsistence farm for the explicit purposes of burning either gas fuel or liquid fuel or both for the production of electric power generation. The design is singular only with respect to the physical design by each designer. The basic principle is standard, and farmers, whether of the subsistence farming class or of the industrial farming class, can actually benefit from the deployment of such technology. And it is a wrap. On that note, I say to you, thank you so much for having come to listen to this observation about efforts aimed at alleviating world hunger through subsistence farming by both urban dweller farmers and emergent country small farms farmers. You are truly appreciated, and if you like to get privileged viewer, reader information, or access podcasts of specialized contents, or access even vertically integrated concepts, then I implore you to join my supporter club and enjoy that privileged status. Moreover, while still here, do please take a moment and subscribe to the channel as to be informed of the publication of every new episode as soon as it is released. Thank you. Bye. Till next episode.